and welcome to another episode of Space Explorers, the show where we're comparing video games to real-life science. I am Seb Ford, and I'm joined, as always, by Professor Lewis Dartnell.
Hello again, still here?
Yes, and Lewis, who do we have today?
Today we have Ryan MacDonald, who's... Well, you're an astrophysicist, aren't you? Maybe you should let yourself...
Yeah, I'm a theoretical astrophysicist working at the University of Cambridge. I focus on trying to figure out what the atmospheres of exoplanets are made of, so that hopefully one day we can find signs of life elsewhere in the universe.
Well, there you go. Is that all you do?
Yeah. Well, no.
I mean, it doesn't sound like much, does it?
I mean, on the side, when I'm not
doing that,
when I'm not just looking for life in the universe by reading the atmospheres of extrasolar planets through the galaxy.
Well, I figure if you want to find life elsewhere in the universe, you can either use telescopes, such as the Hubble Space Telescope, or perhaps you can consider going somewhere yourself. So a few years ago, a few years ago, I actually signed up to a privately organised mission to Mars called Mars 1. They're still in the process of whittling down applicants, so potentially I could be one of the first scientists to go to Mars.
And what sort of shortlist are you in? You're still in the process, aren't you?
Yeah, so there's 100
It's like
of
the
us
X
around the
Factor
world
of going
at
to
the
another
moment.
world, and you're top 100, you're saying?
Yeah, we're in the final 100 at the moment. It'll be whittled down to 40 later in this year, and then finally up to 24 will go into training next year.
That's absolutely insane. Ryan, you've actually played this game before, haven't you?
Yeah, Planetbase. I mean, there's very few games around the place where you really get a chance to develop a colony on another planet that actually has some really decent science backing it up. So I would really describe this as a hard science fiction game, and that's always good to see.
Yeah, and we've only got the first planet option. I couldn't help but notice it is red. It's not strictly called Mars.
It's not Mars, but it's Mars.
But we'll call it Mars. The first and most important thing is, where exactly would you like us to land?
Oh, that's tricky because the closer we are to the equator, the higher the light intensity that we will receive from the sun from the
So
angle.
good for solar panels.
Yeah, so good for solar panels. But then equally, the closer to the poles we're at, subsurface ice deposits would also be closer to the surface. And so it'd be easier to produce
So about
water.
halfway, you reckon?
So yeah, around 45 degrees latitude would be a good place.
Okay, so I'm going to go...
So go about
roughly
45 degrees north.
There we go.
Yeah, and then it shouldn't really matter that much, the longitude.
No.
So just go somewhere where it doesn't... Actually, maybe a place with a crater would be a good place to go because the atmosphere is much thicker on the way down, so we have longer to slow down.
Ah, genius. All right, well, I can't tell what really is a crater, but I'm going to say...
Well, just don't land on a mountain.
I'm
Go
going to say
that dark splodge.
That looks like a crater.
Okay.
A kind of not quite circular one. Ryan MacTopia. All right, start game. The very first thing is...
So we
This
see
is our landing
retrorotic
sequence.
deceleration slowing us down to the surface.
And this is exactly the same kind of technology that's been talked about for Mars 1, is it? This is how, potentially you, but certainly some of the Mars 1 astronauts...
Well, definitely. In particular, the private company SpaceX is really pushing forward the technology for retrorocket deceleration. Okay. They've already had a few landings. So, this is the kind of technology you need to land something as heavy as that on the surface of Mars.
And exactly how heavy is this in real life?
Oh, well...
I mean, not based on its
looks,
size.
well,
Is this
from
like
what we're
10
seeing
tons,
there...
5 tons?
Oh, that looks
roughly?
more like between 40 to 100 tons, I would say. Particularly given all the cargo which will be inside
All right,
there.
okay.
So if I click on
So we've got a
there,
very
here's
full
all the cargo
ship.
we've got. We've got some metal, we've got some bioplastic. These are sort of building blocks. Pasta, delicious. Spares and some medical supplies. So we can do some base building up here. What is the first thing you'd like?
Well, people need to be able to actually get inside the base from the exterior environment, so we should construct an airlock just to start with.
Airlock. Okay, can do. Actually, I do think we're kind of in a crater here.
It is a crater, isn't it? It's got walls around the outside. It's kind of
Yeah.
circular.
If I'm going to build it about there. Would you like some oxygen, for example?
How much do you fancy breathing while you're on Mars?
Well, the unfortunate thing is that outside on Mars, we're about 95% CO2 out there, so we really should get going with producing roughly about 22% oxygen.
So while Seb's building that, talk us through what is the technology behind making oxygen, not just in this game, but as you say, this game is very scientifically accurate. So how would Mars colonists in the future make air to breathe?
In the northern hemisphere on Mars, it used to have a large ocean of liquid water about 4 billion years ago. And much of the water is still there on Mars, just frozen beneath the surface. So if you can dig up some of that frozen water...
So we can dig up some ice
surface,
from underground.
Dig up some ice, and then, of course, water, 2 hydrogens and oxygen, H2O. We can split that using electricity, And you see, we're building a solar panel now to produce
Very well
that
done, Seb.
electricity.
You're flying this solar now, aren't you?
In the name of just making sure that we don't suffocate inside our own spacesuits, I am pressing ahead.
Well, I'm
so you
seeing the red warnings already.
from your solar panels to split the water to make oxygen,
to make hydrogen
and hydrogen,
oxygen.
which maybe could use as a rocket fuel.
Yeah.
Hydrogen could potentially
well.
be used as a fuel as well. So the oxygen, you don't want to have a pure oxygen atmosphere to breathe. That was actually what they had on the Apollo 1 mission, for instance, which
that's
tragically
a huge
caught
fire
on
risk,
fire.
yeah.
So instead, you want to have what we call an inert buffer gas. In the case of our own atmosphere, that would be nitrogen. So, but the problem is that on Mars, although there is some nitrogen in the atmosphere on Mars, there also is a lot of another inert gas called argon, and you can't really split the two. So what you would do is you would collect some nitrogen and argon from the Martian atmosphere and mix that in. So we're talking probably about 20% oxygen, and then roughly a half and half mix, adding up to 70% of nitrogen and argon.
But argon is already used on Earth for like deep sea divers and things.
Yes.
It's a tried and tested technique. It's something we already know about.
Yeah, but it's not dangerous. It's
noble gas. It
it's
doesn't
got
do anything.
well, it's got
I'm
full
happy
electron shell. So
to let you know that we
it doesn't
have
interact.
oxygen on our base now.
Beautiful.
So we have
So
oxygen.
we have power, we have air.
Well, I mean, I say we have power. We've got a trickle of backup power as night begins to fall here.
And our solar panel isn't going to be doing quite so much.
Off. But I do have a battery, and we can tell by how full it is of battery liquid that it
Power juice.
it has hopefully enough to take us through the
Well, our
night.
power's going down quite a bit already, so maybe you should build a wind turbine, for instance.
Okay.
We should say, though, that it's a
So
little bit
would they
more
work on
tricky on
Mars?
Mars. So, on Mars, because the atmosphere is so much thinner than our own atmosphere, we're talking about 0.6% of the density. It means that wind turbines don't really work that well on Mars. There's just not that much kinetic energy flowing through them. So even though the winds can actually be faster by a factor of, say, 2 or so on Mars, in fact, even if they're 4 times faster, and the kinetic energy goes to the square of velocity, so you get 16 times more energy, because the density is less than 1%, overall it means that wind turbines, for about the same cost, only produce a tenth of the energy a solar panel would. So it's clear that the planet we do have here must have a much thicker atmosphere than what Mars does in reality.
And this was one of the points from the beginning of the film The Martian, wasn't it? There was this huge global dust storm in The Martian, and Mark Watney was blown off his feet. But even in the strongest storms on Mars, that because the air is so thin,
you could just walk outside in the middle of a dust storm on Mars and you would barely feel it. You seem to be having some power problems potentially.
I'm having some small to medium-sized power issues. What's wrong with my oxygen? There isn't much of it.
Your oxygen is going up though,
it is,
so it's restoring.
Yeah, I see. All right, so I've just built us a canteen because snacks are
People
important.
like to eat.
I'm just going to take the lid off this so that we can see what we're doing.
Well, we already have a water supply, so let's let people have a way to actually access the water. So let's construct a drinking fountain.
1 drinking fountain.
Great. And then also a vending machine and a table for people to sit at and enjoy their meals.
All right. I'm going to go for 1 single table.
And what would you actually grow to eat in a Mars colony?
Well, before you're even growing any food, we have some food that actually came with us.
Yeah.
So you'd have to, in the case of Mars, bring about a 2-year supply of canned food at
So
the
you're
beginning.
eating canned foods and microwave meals for the first 2 years when you're over on Mars.
Well, that's more in case all your crops fail. It takes roughly 26 months until the planets are aligned again for what we call the Hoffman transfer maneuver to actually send a new mission to Mars. So in the worst case scenario where all your crops die, you want to make sure you still have food to survive for the first 2 years. So
I don't know if you saw that, but there was an asteroid that just landed over there.
Okay.
How sort of dangerous is the planet's surface in terms of being bombarded by things that, say, we take for granted here in the UK, like rain?
There not being that many asteroids.
Where we're somewhat fortunate in that because we live on a planet that has a quite thick atmosphere, it actually burns up many of the smaller meteorites that can come down. But then Mars does have the advantage that because of its lower gravity, the average impact has much lower velocity when it actually hits the surface once it rolls down the gravitational well. And we're still alive after one day.
look at that.
Wonderful.
One day.
Well done, Seb.
I believe that is what they call the lunar hurdle. I've just made that up. That's probably not lunar, is it? It's,
Martian
hurdle. Yes. Yes, we don't actually have beds yet, so no one's actually been to sleep in this first day. But so far, we have an airlock, we have oxygen, we have water, we have power, we have dinner, and soon we will have beds.
Unfortunately, the day on Mars is 40 minutes longer than the day on the Earth.
Get
so
more
you
done.
Can catch
Get
up on
more
that
done.
Guys
sleep.
are absolutely knackered already. But I'm going to see how quickly we can progress to anti-meteor lasers. That's my goal.
The key question is, how do we actually land things that are this heavy on Mars at the moment? The heaviest that we've landed so far is the Curiosity rover, which just weighs about 1 metric ton.
Yeah.
And as you see from the giant cargo ship there, we're going to have to
We're
figure
talking
out
like
how to land
100
things.
times more than that. We're talking a lot more.
If you want to just do people on a one-way trip, maybe around 5 tons you could do.
It's not a very nice place to be.
Maybe you should build a plant
Okay.
to go next to
Of
the
course.
dinner table. There.
Is
So people
it
will be a
that
little bit
simple?
happier.
I believe it is as simple as that. A nice plant.
Or maybe give them a telly.
It costs 1 plastic. I think that is a
Plastic
small
plant.
A small
That's
price.
so depressing. That's an IKEA plant to change
But
the mood of the
I am
entire
going to
base.
spoil them. I am going to give them a telly. They can
Don't
see.
put it behind the vending machine.
Oh, of course. I'm an idiot. There we go.
There we go.
Telly's over there.
We should check how many resources we have as well, because at some point we'll have to produce our own resources. And that's actually a big problem on Mars. If we want to be self-sustainable in the future, we can't just build a few habitats and then wait 2 years before we get the next
Something
supply
more
of
comes,
metal.
yeah.
So you'd have to figure out how to extract resources on Mars and turn them into building materials, for instance, using things such as 3D printers.
Yeah.
I realised while I did build a dorm, I didn't put any beds in it. So everyone's getting a little bit fatigued at this point. So I'll put 2 beds in just for now. I'm very sorry, people. So the biodome is where we're going to grow all of our crops. And the storage is where hopefully I can recycle this ship soon. Get all of these leftover supplies into storage just so that I can reclaim some metal out of this as well.
On Mars, we need people who don't just, when there's a problem, call up mission control and say, Houston, we have a problem.
Because you've got a 20, 40-minute wait for the answer to
Absolutely.
come back. Yeah.
Mars is so far away that even light, the fastest thing in the universe, takes 40 or so minutes to travel there and travel back. So you have to have people that can think on their feet and creatively solve new problems. So you have to train people to solve problems that you haven't thought about.
Anticipated. It's the unknown unknowns, isn't it?
Absolutely.
That's the problem.
That's why it takes about 10 years realistically minimum to train someone for a mission to Mars. You've only actually built 1 life support system with the oxygen generator there. And if
I noticed that as well, Seb. I was
that,
waiting for you to spot it. I didn't want to be the person to drag you down.
I'm just one of those optimistic guys that just goes, I believe that meteorites are going to land here, here, and here, but not here.
However, you have built a second power storage, and this goes into the important principle of redundancy. For every mission-critical component, you want to have at least 1 copy, ideally 3 or 4 copies of them. So in the case of Mars 1, for instance, they want to actually have 4 copies of the life support system after a few weeks of the first crew landing.
Yeah.
The first crew lands with 2 copies, 2 weeks later, 2 more copies land.
Oh, wow.
So
okay.
that doesn't guarantee you are completely safe, but it provides a reasonable level of redundancy.
It's a significant buffer compared.
Yes.
So, say a device like your life support system fails. What kind of, in a habitat that you build, like what kind of window of repair are you talking about? You were saying, well, you don't have time to phone home. You have to get on and fix it. How quickly do you have to fix it?
So Mars One have actually been working with a company called the Paragon Aerospace Development Corporation to design their life support, and they're currently targeting a 1-hour downtime for how long it actually takes to just replace a part and then fix it.
It takes me about an hour to wash dishes. So, you're talking about taking part an immensely complex machine.
Well, I guess the idea is you just take out one module and just slide in a replacement and then worry about trying to repair it
You
later.
want to make everything as modular as possible, and in particular, if you can have 3D printers to make replacement parts, that would be hugely beneficial, for instance.
Current welfare has improved drastically from very poor to good.
With our plastic plant.
And you're right, all it took was a plant and a TV.
People are simple to keep satisfied.
I like to think
aren't
that the TV is not yet showing reruns. They're still working through the back catalogue of videos they took with them. So that's why welfare is currently still good.
So how far are we developed in the science and technology of this side of things, of mining ores on Mars, how we would find those ores in the first place? How would you smelt metals on Mars when you don't have things like coal or firewood or oxygen to be doing that smelting process?
So it's a tricky question, because most of the measurements we have of mineral deposits on Mars are actually from satellites, for instance. We get some base level information about sedimentary rocks from rovers like Curiosity, but not the kind of deep materials that we would really be interested in. Now, of course, we know that there's plenty of iron on Mars. I mean, that's the reason why
red,
Mars is red. Iron oxide, just rust coating the surface. So from what we've learned from all the satellite measurements, it appears that all of the resources we would actually need to be self-sustaining on Mars are actually there. Unlike on the Moon, for instance, where we would actually have to ship some resources up there, for instance. But it's still an outstanding question as to how we would actually process and what's the most efficient way to do that. What food are you actually growing for the people at the moment? What does the Martian diet consist of?
Currently, the Martian diet exclusively consists of lettuce, a nice starchy wheat, so that I can make some plastics. Sorry, this is quite tricky to control. Maybe if I rotate slightly, I might find this a little easier. I believe that's a little tomato pyramid there. And then over here, I've got some medicinal plants. So we've gone and jumped ahead to a previous save so that we've built a slightly bigger planet base. So we've got a few more things installed, including our radar dish, our water tower.
I guess with the water tower like that on somewhere like Mars, though, you would now just have an ice tower. You've got your great big reservoir of water exposed to the freezing cold air.
It is dangerous working here. We've got a couple of broken bones. Jimmy's feeling much better, though. So
people are talking a lot about telemedicine and kind of robotic surgery and things for space missions, aren't they? You can't send your entire crew and have everyone trained up in everything you need in terms of surgery and medicine. You try to do it remotely as well as you can.
It's been tried on the International Space Station. So in the case of Mars 1, they're actually taking the approach of trying to make about half of all people in the first few crews actually specialise in medicine, such that they don't have to actually try telemedicine practices.
I'm assuming that's the kind of situation you want to avoid, of we only sent one doctor and the doctor is sick.
Exactly. I mean, that's why Mars 1 wants to send 2 doctors in every crew, just in case your doctor actually gets ill. Although, fortunately, you wouldn't have to worry that much about getting a cold or infectious diseases on Mars, because obviously, if you have 50 million miles of empty space protecting you from the nearest infected person, that tends to stop the spread.
Yeah, exactly. You aren't going to come down to any pandemics or anything that requires people to transmit.
Importantly, I'm happy to report that we now probably have the facilities to build an anti-meteor laser.
Do it.
Which,
Do it
as
now.
I said, was the ultimate goal here. It's only one size, though. It's a one-size-fits-all laser.
Okay.
It's also an... shall I keep it quite central?
Yeah,
I can't...
coming in.
Unfortunately, I can't put it in the middle of our base. This, I believe, is the telescope looking
Does
for
it need to be close to the telescope, or is that not?
No, it can be
if
anywhere.
It's in the centre of the base, it will have to rotate around in order to be able to shoot a meteor coming from any direction towards the base. If you put it off at the side, it will have a continuous field of view pointing out over the base, so it won't have to turn that much to hit a meteor.
Smart. See, I hadn't given that any consideration at all.
So maybe to the right slightly.
Okay, we'll attack it onto our existing... I'll only give it one connection for now. Our existing power grid over there.
Now, I've noticed that there's one thing that seems to be somewhat missing from the game, in that there doesn't seem to be like research laboratories, people actually reaching and doing science actually on the environment.
Which again begs the
themselves.
question: why would you go to Mars in the first place? You don't go to Mars just to build solar panels and wind turbines and keep yourself alive. You've gone there to do something, haven't you? Gone there for a job.
Yeah.
Here's the research that we haven't yet purchased. No one's doing the research. We're just simply living our lives.
See, this is why. If they had a laboratory, they could invent the Goliath turbine themselves.
I know. It seems such a logical thing to invent, the Goliath turbine and the massive storage patent. There's nothing stopping them except illegal ramifications.
Damn Earth laws.
Yes.
So what science would you have in mind to be doing when... I say if/when you get to Mars?
There's so many fascinating science questions to solve on Mars.
Top 3.
Has Mars ever been habitable? Or, well, not habitable, inhabited.
Yeah.
Has there ever been life on Mars? We know it was actually habitable 4 billion years ago. If we do find that life, that leads into question 2, which is, what is that life actually like? Is it related to Earth life? If not, how is it different? How did it start, for instance? I mean, I'm going way over the number of questions here. And then there's also questions...
These are sub-questions from your main points,
yeah.
I think.
And then I think those are questions looking at the past and the present, though. My third question would be looking at the future. It would be concerned with how we might consider trying to make Mars become a habitable planet again in the future, which is, I would argue, the long-term goal of why we want to go to Mars, because unlike any other destination in the solar system, Mars would be relatively straightforward with existing or future technology.
And this is terraforming, isn't it?
Absolutely.
This is what you need to do.
It's called terraforming.
What could humanity do to Mars to make it more Earth-like, so you could live there and walk around without a spacesuit on?
So the first step is you'd really want to thicken the atmosphere. Even if you can thicken the atmosphere without there being oxygen in the atmosphere, then you could walk outside without a pressure suit, just with an oxygen mask on, for instance. So you want to thicken the atmosphere substantially.
How does one go about thickening a planetary atmosphere?
Well, so in the case of Mars, there's actually the fortunate scenario that a large part of the ice caps on Mars is actually frozen carbon dioxide or dry ice. So if you can heat up the planet slightly, you get 2 birds killed with 1 stone, really, because you thicken the atmosphere by subliming, turning from a solid into a gas, the CO2. And then the CO2 also creates a greenhouse effect to warm it even more and start to then
So you get a feedback process.
You get a feedback process. It would be difficult because we need to heat up the planet by about 50 degrees Celsius even to get it to the point of being at freezing. It's about minus 50 on average at the moment. You could speed it up by releasing super greenhouse gases into the atmosphere. There are some compounds called... Well, see, I love that.
You say that with a straight face because you've clearly said that enough times that you are now immune to it.
Consider that we're doing a pretty good job of warming our own planet and we're not even trying.
Inadvertently, yeah.
We know certain compounds, namely perfluorates, which are about 9,000 times more potent than CO2 as greenhouse gases.
So we could do this. We could build some kind of colony on Mars, give it industrial capabilities, give it a factory, and start pumping out, deliberately releasing super greenhouse gases.
There's one, octafluoropropane, I believe is its name.
Wow.
That is one that if we could release a couple hundred tons into the atmosphere, could warm up the planet by 10 degrees Celsius.
Okay.
So don't tell the supervillains, because 10 degrees Celsius would be a disaster here on the Earth.
Wow.
So if we've already thickened the atmosphere and we've gradually started to warm it up to above freezing point, then parts of the ancient ocean of liquid water that used to be on Mars, which is now beneath the surface, will start to gradually emerge on the surface and start to fill in the northern hemisphere. There's a large depression where this ancient ocean used to be on Mars that would start to fill gradually. There is actually enough water on Mars itself to cover the entire planet to a depth of about 30 meters if you were to melt it all. We wouldn't melt it all.
And that's the water we see in the polar caps?
Not just the polar caps, but also just underneath the surface all over the planet in the permafrost. So there's plenty of water already on Mars. So you would gradually restore the ocean. So then you're imagining a planet with an ocean, a carbon dioxide atmosphere, and you could walk out on the surface just with a mask, for instance, to provide oxygen. That's relatively straightforward to do if you have deep pockets. It would probably take about 70 years or so to get to that point if money wasn't an issue. The big issue, though, is how do you change the atmospheric composition to make it such that you can breathe it?
Yeah, so we want to make oxygen again, but on a whole planet and not just for electrolysis and the colony.
Yeah, so if you're not that worried about time, you could use genetically modified plants on the surface. And you can't just put down trees immediately because there isn't soil already on Mars. You'd have to have basic algae that then dies, and over many generations they create the soil layer and add the nutrients. So it would probably take about 10,000 years or so just using plants. But again, if money and resources aren't a problem, you could actually have factories that take in CO2, break the carbon-oxygen double bonds, and actually output the oxygen directly.
So artificial trees, essentially.
Yeah, artificial trees.
Factory trees.
What resources do you have at the moment?
Let's have a look. So currently, we've got some good food, a lot of plastic, not a lot of metal.
I believe it's 10 metal and 10 bioplastic. Then you could build the giant monolith, which solely serves for vanity.
I really want to build a giant monolith.
Yes.
Can we build a giant monolith?
All right, so
have we got a giant
goal.
monolith yet? Where's our monolith, mate?
I'm working on the monolith. Okay, first things first. We need to build a signpost.
Oh, do you need to build up to it?
So that we can build the pyramid, so that we can build the monolith.
Nothing's easy, right?
Yes. The pyramid is 95% complete.
Looking good. It's looking a bit like the Louvre. We've built an arts gallery on Mars.
Sandstorm is imminent.
We've got our first dust storm, so maybe we should sound the alarm to get people inside.
What level of alert?
It's pretty urgent, isn't it? Go for red?
Let's go to yellow alert.
I mean, let's not debate too long about what kind of alert it is before sounding it.
All right, so we're at yellow alert, which I think means that the medical staff and the guards are on higher alert and everyone else has just gone to bed.
And people come in from the outside? People are rushing to the airlocks right now?
They will rush to the airlocks.
Although, are we going to generate lots of electricity with our windmills, with the turbines now? Or do we have to block them to protect them?
The wind turbines will work slightly more efficiently because the wind speeds do generally tend to be larger in a dust storm. And that's good because the solar panels are completely useless at the moment.
Yes, they are completely useless. But yeah, winds on full at a full 60 meters per second, which is pretty nippy.
That's pretty fast.
Yeah.
That's decent.
But I'm glad to say that our pyramid hasn't taken any damage in the wind.
And it's not useless. I actually noticed it's giving us 30 reputation, so people want to come and see our giant pyramid.
Yes. But more importantly, and as soon as this sandstorm is over and everyone is safe, I think there's one final construction that we need to do. But the monolith is an epic and totally pointless symbol of achievement. So let's build one right here.
Now we're going to see
Will.
some epic
Will is
additive
on the job.
manufacturing here.
This
Building it
is
layer
what
by layer.
this is what it's all about. Yes, everyone, come on, come all.
Come see the monolith.
Come visit the monolith.
Why are we building it at night though? That seems to be missing out a lot of the effect.
It's okay.
Because everyone wakes up and now sees this humongous monolith out the window.
It is pretty.
Here we go. And the sun rises just as the monolith completes.
Very, very artsy.
We can tell the time with it, of course. Look at that. That is magnificent.
Oh, look at our
Behold
monolith.
the
The monolith has been built.
Megalomania
Megalomania achieved.
Yes.
End of game. Well done us. Well done, Ryan. Thank you for talking us through that.
Great.
Yes, I think that.
I don't think we killed a single person. We at least didn't kill
We
everyone.
have a very
once.
good safety track record.
Yes, I actually believe I did kill 2, but you guys were
Quietly,
very,
no one noticed. You could have
very,
totally
very
kept
busy.
that to yourself.
So I will keep that to myself. But yes, monolith achieved, which means space conquered. Ryan, your thoughts on the quality of my base building, please.
Well, no one's died. We managed to intercept a few meteors. Mm-hmm. And so it looks like this is a quality start to begin a new terraforming
We had
project.
a
on this
bunch of
planet.
visitors. We can now move on
Yes.
to changing the whole planet.
Exactly.
Absolutely.
Yes. Now, Lewis, who do we have next? We have one last guest before yourself.
Yes, next up we have Abby Hutty, who is a literal rocket scientist. She works designing and making space probes to go to Mars. She's working on the ExoMars 2020 mission. So I'm very much looking forward to talking to Abby.
Yep.
And the game we're playing with her is, Seb.
It's going to be Kerbal Space
It is
Program.
Kerbal Space Program. I
yes.
completely
Yes,
forgotten.
well,
I'm
of
glad
course,
that you
no.
remembered.
If it's a literal rocket scientist, we need to be building literal rockets.
With little people.
With tiny,
little rockets
tiny
with little people.
Yes. So I'm very much looking forward to that. I've not built a rocket before. That was a complete lie. I have built a rocket before, but I'll tell you that
This
story.
is your fireworks story with the police helicopter, isn't it?
It is the fireworks
We
story.
will
of the police
come on to
helicopter.
that another
Make
time.
sure that you tune in for the Abby Hutty episode of Space Explorers, where we talk about police helicopters and actual space rockets as well. But until then, I suppose there's nothing left but to say thank you very much, Ryan.
No problem. My
Yes.
pleasure.
Ryan.
All the best on Mars. And don't forget to tune in for the second part Q&A with Ryan as well, where we're going to talk about everything in Mars 1, everything to do with his research. And also thank you very much, Lewis, as well.
Thank you for having me. And I'll see you all again soon.
Yes.
See you soon.